Welcome. So a dilation is a transformation that produces an image that is the same shape as the original, but is a different size. A dilation stretches or shrinks. If it stretches, it's called an enlargement. Come on. It's called an enlargement. Right? And by the way, there's a lot of fill-ins in the beginning of your notes, so just make sure you're filling in along. If it shrinks, it's called a contraction. Okay? So a dilation either stretches, makes it larger, and that's called an enlargement, or it makes it smaller, it shrinks it, and it's called a contraction. A dilation used to create an image larger than the original is called an enlargement. A dilation used to create an image smaller than the original is called a contraction. So when we're describing a dilation, we have to include two things. First, the scale factor. So a description of the dilation includes the scale factor or ratio. And second, you have to include the center of dilation. So the center of dilation is a fixed point in the plane about which all points are expanded or contracted. A scale factor describes how much the figure is enlarged or reduced. So very important. If the scale factor is greater than 1, the image is an enlargement. A lot of times we call scale factor, we use the letter K to describe our scale factor. So we'll say K is some number, and that's our scale factor. If it's greater than 1, the image is an enlargement. If the scale factor is between 0 and 1, the image is a reduction or contraction. We'll find out what happens if our scale factor is negative later on in this podcast. All right, so here, this one here happens to be a contraction. I believe this is in your notes as well. And we can tell because notice that the image is smaller. Right? So here's our pre-image. There's no prime marks. Here's the image. Since it's smaller and closer to the center of dilation, oh, there is the center of dilation, right? Then we know that that has to be a contraction. Right? Our image got smaller. Right? And for a dilation, all of our corresponding angles are going to be congruent. So here we know that angle B prime, whoops, well, the arrow did not want to go there. Angle B prime is congruent to angle, come on, so we can point, angle B. It's not going to go there, it's too close to the edge. Oh, look at that, it went after all. So angle B prime is congruent to angle B. Angle C prime is congruent to angle C, and angle A prime is congruent to angle A. All your sides are a certain percent larger or smaller, depending on whether the dilation is an enlargement or a contraction. Some things stay the same under a dilation, and some things change. Things that stay the same. Orientation and angle measures remain the same under a dilation. It's going to be facing the same direction. Everything's going to be in the same order. These are things that change. Length of sides, perimeter, area, and position change under a dilation. The only time those wouldn't change is if the scale factor was 1. Right? And in which case, it's really, I mean, technically you can call a scale factor of 1 a dilation, but that would be a dilation that creates a congruent figure. I mean, that's usually not what we're talking about when we have a dilation. We're talking about a dilation that changes the size of the figure. All right? So let's continue on learning about dilation. So this lesson we're just going to be learning some basic facts about dilations. All right, so size change is a similarity transformation, and we know size change is called a dilation. I know this particular slide is in your notes. I believe there's some fill-ins. Anything that's not written in your notes already, make sure you add. Your corresponding angles will always be congruent under a dilation, and the sides will be in proportion. All right, so here is our pre-image. Right? We can see that AB is 3, AD is 6. By the way, this is supposedly a rectangle or parallelogram. So the opposite sides are going to be the same. Otherwise, if they weren't the same, they would have told us. The opposite side here is 6, this side here is 3, right? So the ratio of our corresponding sides, if we match up the corresponding sides, so here we matched up A prime and B prime, and that corresponds to AB. B prime and C prime correspond to BC. C prime and D prime correspond to CD, and D prime and A prime correspond to DA, right? And if you're proving something is a dilation, you have to check all the corresponding sides. If you're just finding the scale factor and you already know it's a dilation, then you can match any pair of corresponding sides. When you're finding scale factor, if this isn't in your notes, add this to your notes. You can abbreviate because I don't have enough room to write as scale factor. To find your scale factor, it's image over pre-image. All right, not the other way around. All right, so the image AB is equal to A prime B prime is 9. The corresponding side AB is 3. B prime C prime, the length of that is 18. BC, the corresponding side is 6. All right, and same thing, C prime D prime is 9. The corresponding side is 3. D prime A prime is 18. Corresponding side DA is 6. Any one of those reduces to 3. That's our scale factor. Our scale factor is 3. This particular dilation is an enlargement. Oh, I have it right down in your notes. I imagine I put that in there. But your scale factor is always the image length over the original length, the pre-image, right? Image over pre-image. Notice corresponding sides are in proportion. I think that's a fill-in for you. All right, so you don't have to worry about writing SF equals image pre-image in your notes because I put it down there. But if I didn't, then make sure you put that in. But I'm pretty sure I did. All right, so, and this is in your notes exactly because I checked. I was going to rewrite it, but I saw it was already in your notes. So tell whether each transformation is a dilation. If you're asked to figure out if a transformation is a dilation, come on here, you're going to match the corresponding sides and angles. The corresponding angles must be congruent. This particular, we have two rectangles here. Right? We know it's a parallelogram because opposite sides are congruent, and you'll learn next semester that that is one of the ways to prove a quadrilateral is a parallelogram. So this is at minimum a parallelogram, but since it has a right angle, it has to be a rectangle. So we know all of our corresponding angles are congruent because they all equal 90 degrees. Now you have to make sure the corresponding sides are in proportion. You do have to check all of the corresponding sides, right? So image over pre-image, A prime B prime is to AB, as B prime C prime is to BC, as C prime D prime is to CD, as D prime A prime is to DA. Right? And so now we just fill in the side measures. Right? So A prime B prime, that was 5, and AB was 10. B prime C prime is 3, BC is 6, C prime D prime is 5, CD is 10, and it's all just from the diagram. D prime A prime is 3, DA is 6. Every single one of those reduces to 1/2. If any one of those did not reduce to 1/2, this would not be a dilation. So this, since it's pre-image over image over pre-image, is your scale factor. And this happens to be a contraction. Our figure got smaller. All the sides are now half as long. Thank you, Mr. Arrow. I'll see you again on another page. All right, so I said add to notes, but I think actually it does have some information that's not in your notes. So add this into your notes. The diagram would be really helpful. I'll call it optional, but I think it would be very helpful. But I definitely want the types of dilations in your notes, as well as some descriptors for contraction and enlargement. I would draw this in because then you'll have a picture. All right, so I thought I had an arrow. Oh, I'll just make my own arrow. All right, so contraction. There we go, arrow. All right, so contraction. Your image is, well, so much for my arrow. Come on, arrow. Your image is smaller, and you're going to be closer to the point of dilation. All right, so here RST is the original. That's the pre-image. I'll write pre-image underneath that. Right? Your contraction, right, R double prime, S double prime, T double prime, right, is going to be, notice, closer to the point of dilation. Your center of dilation here is C. You can call it point of dilation, center of dilation, same thing. If a dilation is an enlargement, figure is going to be larger, and the points are going to be farther away from the point of dilation. Right? So here, R prime, S prime, T prime is a dilation, and it's an enlargement. All right? So notice that it is not only larger, but it is farther away from the center of dilation. Right? So if it's an enlargement, it's going to be farther from the center of dilation, as well as being larger. By the way, if I end up redoing your notes a little bit and I end up adding this in, then you would just have to add in the extras. If you don't see this image in your notes, then no, you got to finish it. You got to put that in because that would be very helpful for you. All right, this one is just going to show you a dilation. C there is our scale, is our center of dilation. This is going to have a scale factor of 2. That means the image is going to be twice as far from the center of dilation as the pre-image, and the sides are going to be twice as long. Right? So the distance from C to R prime is going to be the same as 2 CRs, because it's twice as long. Likewise, the distance from C to S prime is going to be twice as long as CS. So that means it's going to take 2 CS's to equal 1 CS prime. And the distance from C to T prime is twice the distance from C to T. So that means it's going to take 2 CT's to equal 1 CT prime. All right? So all the distances are going to be twice as much because their scale factor was 2. And there you can see RST is similar to R prime, S prime, T prime. A dilation is a similarity transformation. It creates similar figures. We'll talk about similarity transformations in not the next lesson, but the lesson after it, but I thought I would write it in here. Right? And it creates similar figures. They have the same shape, same angle measures, and the sides are going to be in proportion. In this case, since our scale factor is 2, the sides are going to be twice as large as the sides for RST, and the distances are going to be twice as large as well from the center of dilation. Everything is twice as large, except area. You'll find out the difference, how area is affected. This one is in your notes, but with the numbers filled in. What kind of dilation is this? We can see our center of dilation. All right, our center of dilation is C. How do we know that's the center of dilation? Notice that our points for the original and the pre-image and the image are all on these line segments that all start at C. So your center of dilation is C. Your image has the prime marks, so it's F prime, G prime, H prime, and K prime. And this is a contraction. Our image is smaller than the pre-image. Excuse me, yes. Our image is smaller than the pre-image. I said what I meant to say. All right, let's look at how much smaller. And you have this one in your notes, and we're gonna solve some problems with this one. All right, so we want to prove that this is a dilation, right? And so not only are we going to find the scale factor, we're actually going to prove it's a dilation. You're going to find out that when we're done, our scale factor is going to be between 0 and 1, which means it's a reduction or contraction. Add the words contraction underneath that. You have what's written in there already. So to prove a dilation, you match all your corresponding sides, and it's always image over original or image over pre-image. To find the scale factor when you know it's a dilation, match any pair of corresponding sides. So here we want to actually prove, right? So that means that we have to match all the corresponding sides, right? And if we want to make sure that we actually find the scale factor at the same time, we're going to have to make sure it's image over original. All right, so we're going to find the ratio of FG. Oh, excuse me. I meant to write F prime G prime. Ignore that. F prime G prime over FG. All right, and that's going to be 15 over 45. Always reduce to lowest terms. All right, so that's both divisible by 15. 15 divided by 15 is 1. 45 divided by 15 is 3. And if you didn't know 15 divides evenly into 45, well, you could just divide them both by 5, and then you'd see, oh, you can divide by 3. All right, so then now let's match up the next pair of corresponding sides. All right, so G prime, H prime to GH. All right, so G prime, H prime, that one's also 12. All right, these are rectangles. So that's going to be 12. And GH is 36. That reduces to 1/3, right? Because 12 divides into 12 one time. 36 divided by 12 is 3. Now we need H prime, K prime to HK. All right, so H prime, K prime, that's 15. And HK, that one is 45. So of course that's just going to be 1/3 because we already had that. And then the last pair of sides are F prime, K prime and FK. F prime, K prime is 12. FK is 36. And that of course reduces to 1/3. All right, so now we can see we have all of our corresponding sides are in proportion. All right, so that means, and our angles are all congruent. I didn't mark it in here, but we'll also have to show that our angles were all congruent. But this is a rectangle, I will tell you that. I think I erased my angle measures. All right. So F prime, G prime, H prime, K prime is similar to FG, HK. Need a little bit more space. Really should have written this a little smaller. Can we squeeze it all in? Come on, where's it? There we go. Maybe if I move this over a little bit. Here, let's do this. Boy, it's taking a long time. Oop, there we go. There we go. Later on I'll move. There we go. Now it's moving. All right, you move over there, and you move over there. And now I don't need that really crooked line. That's good, because that's really crooked. Takes crooked to a new level. There we go. Because, actually, let's use the abbreviation for because. So here's the symbol for because. It's just like my symbol for therefore, except it's upside down. So looks like like a triangle with 3 dots. Because all corresponding sides corresponding angles are congruent. Because they're all 90 degrees. And corresponding sides are in proportion. I didn't want that line back after all. See if I can make it straight though. Well, it's straighter. Right? So to prove a figure is two figures are similar, you have to show that all the angles are congruent and the corresponding sides are in proportion. Right? So we have figured out our scale factor. That was 1/3. And we figured out that these are two similar figures. And this has to be a dilation. Right? So if these are similar, this is a dilation. One last thing that we're going to look at in this particular podcast, and you don't have to take notes on this one. Well, actually, there might be one thing you want to take notes on, but I'm going to show you, we're going to look at a dilation off the coordinate plane, and you're just going to look, you're going to just kind of sit back and watch. Size change is a projection. So to change the size of a figure with a projection, we need a point of dilation. Our point of dilation can be inside, outside, or on the figure, right? And there's actually a way you can do a dilation when it's not on a coordinate plane, right? So, and now you'll know how. Right? So these are all pre-images, and the points you see are our point of dilation, or center of dilation. The first one is inside the figure. Let's see what happens. One of them is outside the figure, and one of them is on the figure. We have a scale factor of 3, a scale factor of -2, and a scale factor of 1/2. For some reason they used R here. Most times it's K that's used. All right, so now one of these will be larger than the pre-image. The image will be larger than the pre-image. And on one of these, the pre-image will be smaller. Do you know which is which? Hopefully. Now let's see what happens. One of them is going to be a little bit different than the other two, though. So to show size change as a projection, if you wanted to do a dilation off the coordinate plane, and you can also use this handy dandy little hint when you're on the coordinate plane, you're just going to start from the center and draw rays from the center to each vertex. Okay? And your pre-image and your image are going to be on those rays. Now we would have to, if we're on a coordinate plane, we'll have to measure. But here it's all measured for us. My page didn't change. There we go. Okay, there we go. All right, so we had to measure. All right, so here it's showing you that this little distance here was 1. What these distances were, all right, so this 2, 2.5, 1.5, 1, they're showing you the distances to each of the corresponding points, all right? It's these distances, not the sides of the figure. So those are the distances it's talking about. All right, and then we have 4, 4, and 4 square roots of 2. All right, so that's just from center to a vertex. All right, so now, obviously, if my scale factor is 3, right, my image has to be 3, instead of just 1 from the center of dilation, it has to be 3 from the center of dilation. And if my scale factor is 1/2, instead of 4, it's going to be 2. But let's look at the third one, the one in the middle there. What's going to happen there? All right, so here's all our points, right? So we got 3 times as much. We got 1/2 as much. We have 2 times as much. And then we connect. So here, since our scale, on the first one, since the scale factor is greater than 1, right, the K is greater than 1, the image is larger than the pre-image. On the last one, since K is between 0 and 1, the image is smaller than the pre-image. If you have a negative K, you have a dilation and a rotation of 180 degrees. So the one you might want to add is this one to your notes. We might see it again, but a negative K is a dilation and a 180-degree rotation. So maybe just add that to your notes somewhere. And I believe that's going to be the end of my podcast. So in the next series of lessons, we're going to do dilations on the coordinate plane. So now